So for fractional powers where it's not a half or a third, we have to deal with the numerator, the m, and the denominator, the n, in either order. So if we look at the first example, 25 to the power of 1.5 here, 1.5, we can change that into a fraction. So that's 3 halves. So we're doing 25 to the 3 halves. Now, if I just take a look at the way your textbook has done it, on example 11, page 157, they have square rooted first, and that's the way I would do it because it makes 25 smaller. So if you take the bottom 2, that means square root of 25, and you're yet to cube it, you're yet to raise it to the power of 3. But the 2 here just square roots it. So I know that this all is 5. And yet to cube it, it's 5 times 5 times 5, which is 125. So that's your final answer. For problem B, it's 6 raised to the power of 16. So quarter root of 16, before we do the raising to the power of 3, that means what times what times what is 16. And fortunately for us, we should know that that what is 2. So that whole thing becomes 2, so the quarterth power of 16 is 2, or 16 to the 4th root is 2. So that's how we've got the 2 here, and we're yet to cube it, which is the numerator of that fractional expression. So that brings us to 8, final answer. Okay, for the last one, not too different, except we have a negative in the fractional part. So you need to remember from your power rules that negative means that this term is 1 over the term. So what this is 1 over 8 to the power of 2/3. So we can just leave the 1 and we can just deal with 8 to the 2/3 power. So that would be the same as cube root 8 and then square it. I'd like to cube root it first because that makes 8 into 2, it makes it smaller, and so then I square it, so it becomes 1/4. You could do it the other way and it will come out exactly the same. If you were to do it the other way, basically you would, where are we here, you would square 8, so that becomes 64. So if you were to go the other way, it becomes 64 cubed root, my bad. That's 8 squared is 64, and then I cube root that, and I should also get 4 for that bottom part there. So 1 over 4 would be the answer if you dealt with the squaring up before you cubed it, if you dealt with the numerator prior to the denominator. So that will allow you to do up to question 3 in the section 4.2. So beyond that, we have ones that are a little bit trickier. So we're asked here to express an index form with rational powers. So at the moment, these all have surds. So we want to get rid of the root signs, the surds, and put them as powers. So for the first one, you have 8. Now, because it's a 5 there, we represent that as 1/5. That is fine. You have done everything that the question has asked you to do. You don't have to do anything further. In the textbook, they actually reduce that to base 2. So we just show you how to do that. However, if you get to this stage, you have actually answered this question. You've just put it into a rational power, which is a fractional power. So you've actually done it. What they do, and I'll just demonstrate it here because you are required to do this a little bit with the next 2 problems, is they have changed that to a prime factor base. So 8 is made up of, if you think of 8 as its own power, that would be 2 cubed is 8. And we won't forget that we raise that to power of 1/5 as well. With the multiplication of powers or brackets, we can times that through. So base 2 to the power of 3 times 1/5. 3 times 1/5 is 3/5. And they express that as 2 to the power of 0.6. which doesn't actually really answer the question because the rational part is best left right there. Okay, so I wouldn't actually put it in 1/6, I would leave it as 2 to the 3/5. But either of those answers is okay, even the first one, 8 to the 1/5 or 2 to the 3/5. Okay, next one here, we are doing part B now. It's 9 times square root 3. So let's just write that a little bit fuller. So 3 square root is 3 to the half, like that. What they've done here is they don't want this expressed as a whole number. They want that expressed in index form together with the sky. So if we eyeball this hard enough, we can see that the same base 3 exists in this 9 here. Okay, so we're going to change that 9 to 3 squared. And that's just knowledge, that's just looking at it. So we want to blend that 9 in as a power along with this base 3 one. So let's work that one through. Once we've done that, it's multiplied by 3 to the 1/2. When we multiply numbers with the same base, we add the power. So that becomes 3 power of 2 plus 1/2. Fractionally, 2 plus 1/2 is 4 halves. Let me do it up here. 2 is 4 divided by 2 plus 1 divided by 2 gives me 5 divided by 2. So I've just done the working up here, and that means that we can equate that down here to 3 to the power of 5 halves. That's pretty tidy and exactly what they've asked us to do because they've said rational powers. Rational means fractional. I don't really want to change that into a decimal. I would prefer you guys left it at that rather than changing that to decimal form, 5 halves, 2.5. It's okay as well, but this to me is cleaner. Okay, let's do part C now. So part C, let's have a good look at it. Solve for x, where the equation, for the equation 4 to the power x equals 8 times square root 2. So let's work this one through. 4 to some unknown power is equal to 8 times square root 2. So we've just written that down. 4 to the unknown power is 8 times 2 half root, okay, because square root's half root. So the third step there is to have a look at this 8 and do exactly the same as we've done with part B. We're going to turn it into a base 2. So 2 cubed is 8 and, whoops, 1/2 there. So 4 to the x equals all that. So what we do next is we tidy this one up so it's 1 power, 1 base. So that becomes 3 plus 1/2, which is 3.5. 3 written as half is 6 halves. So I'm just going to do the working of the fractions out to the side. So 3 plus 1/2 is 6 halves, was 3 plus 1/2 is 7 halves. I'm just going to leave it at that, 2 to the power of 7 halves for now. And I'm going to copy down the left side of the equation. So 4 to the power of x equals 2 to the power of 7 halves. Now things get a little bit tricky here because we don't have the same base. We have base 4 and base 2. So I'm going to work this a little bit differently from your textbook to help you see perhaps what's going on. So I can express 4 as 2 times 2. That whole expression is multiplied to the power of x because 2 2s are 4. So now if we tidy that expression up, we have base 2 multiplied by raised to the power of 2 and base 2 raised to the power of 2. So what that becomes there is each of those has an x next to it like that. So 2 to the x times 2 to the x, sorry, that one there should be x, and that simplifies to 2 to the power of 2x. So your textbook got to there, but very quickly. We didn't see quite what was going on. And remember that that whole left-hand side of our equation is equal to 2 to the power of 7 halves. I'm just going to take that through now. 7 halves, 2 to the 7 halves. So to solve that out further, we are going to look at this again, eyeball it, and see that the bases are the same. So if the bases are the same, the powers must be the same. So we're going to forget about the 2 and just take powers, so that power, the 2x, is equal to that power 7 halves, or 7 over 2. Now we've got an expression for what 2x is equal to, and we just want to actually find out what that x is equal to. So we're just going to use algebraic solving to find x equal to something. So on the left side, x is doubled times 2, so what we need to do is divide it over on the other side, which means x is equal to 7 halves. Divide by 2, or times a half is another way to do it. So what I actually do with that 2 that I've taken over, I can put it on the bottom of 7 halves. So x equal to 7 over 2. I'm just going to put a dot there because I'm still dividing that 2 over there, but over that. So if I just work just as algebraically and take the next line for my working, x is equal to 7 over 2 2's are 4, okay, because that's a times. If that was a little too quick for you, another way to actually do it is when you divide by 2 up here, so 7 halves divided by 2, dividing by any number, any fraction, so 2 is a fraction, 2 over 1 is the fractional form of it, we can just go 7 halves times the reciprocal times a half. And so we can multiply across the top, 7 1's are 7, and across the bottom, 2 2's are 4 there, same answer. Okay, so that takes a little bit of step by step, and you just need to respect your fractional operations and how we deal with fractions in those cases.